share the link. Okay. So again, I apologize. My computer literally just shut down for no reason, because they're always super helpful when you need them the most. So we were talking about solving this equation with variables on both sides. And we said we need to minus the 3x from the 5x. And you do combine those together. When you combine together two variables, you just still do 5 minus 3. 5 minus 3 is 2x. And we leave the x attached. We also bring everything else down that we haven't done anything with. So once we do that step, now we want to do the opposite, again, of the number furthest away from x. 2 is immediately touching x. It's right next to. What's the opposite of subtracting 1 here? What will our second step be if we're trying to do the opposite of the minus 1? Good. Add. We want to add the 1 to the number on the opposite side. And then this was our tricky step. What do we do with the 2? What's the opposite of that 2 that's next to the x? Good. I did have a chat message where someone said divide. Divide by 2. And that will give us our final answer. Once x is alone, then we get our final answer here. Again, if this was multiple choice, we could use the method of plugging answers in to see which one works. So solving equations can be used just on its own. They might have you solve just an equation on its own, or they might have you do some patterns that you might not even need to necessarily set up an equation for, but it will involve some solving and possibly doing opposites or looking for a pattern of what's going on. So this one says, an ice cream shop sells 1 cone for $3.50, 2 cones for $6.75, and 3 cones for $9.75. If the pattern continues, how much will it cost for 4 cones? So they give us information about 1 cone, 2 cones, and 3 cones. And they ask us how much it is for 4 cones. So when we're working through these pattern problems, a lot of the time it's going to be some sort of addition or some sort of multiplication. I almost always check the addition first. It's more often addition. Good, I'm glad these are the types of questions you're looking for. Had a chat message again, someone saying these are the kinds we need help with. I'm trying to cover every topic possible so that hopefully we'll hit all the topics you need. So if we're looking for a pattern of addition, I need to know, what am I adding? I usually write it to the side. I say, what do I add to 350 to get to 675? Sometimes that's hard to figure out. So even though ultimately this is addition, to figure out the number it's going to be, you do the opposite. We've got to use those opposite operations in a lot of different situations. If we take 675, subtract 350, that will actually give us the number that we have to add. Let me see if I can bring the calculator up again. Everything got kind of messed up from before. Okay. So if you want the calculator bigger, you might want to do that to see. But I mean, this one's just subtraction. You just type it in normally. 675 minus 350. This one is definitely minus though and not negative. We want to use the minus button, which is 3.25. So that is actually what we're adding. 350 plus a 3.25 brings us up to 675. With every pattern, though, we need to see what happens next. Maybe it's the same number, maybe they've changed it a little bit. We have to do this again and figure out, well, how much does it take to get from 675 to 975? This one you might be able to figure out in your head. It's a little easier than the first one, but you can always just do that opposite again to figure out what we're actually adding. So 975 minus 675 is 3. And since this is money, I'm going to put 3.00 for $3. Good. Someone also sent a chat message before I had finished writing it out. That does come out to be 3. So there was a slight change. With every pattern, we need to figure out, well, what's going to come next? If it was the exact same, we would just add the exact same. If it had been plus 3.25 plus 3.25, would plus 3.25 again. They made a change, probably because the more you order, they're going to try and make it, you know, kind of a deal, so you'll buy more. So we have to figure out, what am I going to add next? And that's the point of every kind of pattern problem. What do I do next? So what do you think we have to add next to follow this same pattern? What change happened from here to here that we also have to make the change for the next one? Good. Someone said 275. They dropped the price by a quarter every time. Sorry, my 7 turned out really weird. Try that again. 275. So we add 975 plus 275. And that's $12.50, which is our answer choice C. So even though this one's multiple choice, it's not the kind where you can plug it in. It is one where you just have to figure out the pattern. Some multiple choice, you can kind of do that cheating way. Some you have to just plug in. Where did the 275 come from? Thank you for your question. So I'm going to go back and answer that before moving on. We got 275 because from 3.25 to 3, they went down 25 cents. They dropped the price by 0.25 to get from 3.25 to $3. So we have to do that again. We have to drop the price 25 cents again to get to 275. And that's where we got that number to follow that same pattern. Good question. Good. Okay, so next pattern problem. Carlos is saving money to buy a car that costs $1,800. The table below shows how much money he has saved up by the end of each month. And I had to handwrite the table in because this program doesn't have a table feature. But it shows, you know, January, he has 200, February 400, March 600, April 800. And then the question is, by the end of which month will Carlos have enough money saved? So on a problem like this, I just keep going on the table. You can actually like write out an equation and use an equation to solve it. That's a lot of effort. It's not worth the effort. It's easier to just keep going on the table. So the next month is May. And we would have to figure out, well, what number comes up next for May? So first we need to figure out the pattern. What are we adding every time to get to the next number? So can anyone see what the pattern is without doing that opposite step of doing some subtraction? What are we adding every time to get to the next number?
All right. Yeah, so that's the plan. So we're working through some. Yeah,
so I don't see any answers yet. If you can't see the pattern, we can always go back to doing the opposite. If we do 400 Oh, okay, now we have one person say 200, and that is the correct pattern. If we do, and another person, good. We're adding $200 every time. So last time the pattern changed. This time, every single one is adding $200. Same pattern every time. And again, if you can't see it right off, do the subtraction. 400 minus 200, it's 200. Then we have to check. I put this little kind of arrow to say we're looking at the 400 and looking at the 600. We do 600 minus 400, also 200. So if we're following that same pattern over and over again, we just keep adding 200. 800 plus 200 is 1,000. We know ultimately we want to get to 1,800, so we've got to keep going. Keep going until you reach the number they specified. So April, May, June, we add another 200. And you can try and do it in your head. For me, that's actually too hard. I always forget one or don't track it well enough. To me, it seems safer to write it out, just so you know for sure I didn't miss anything. So July, we add another 200. May, June, July, August, we add another 200 because we're not quite there. It can be a little time consuming. And if you're doing one of the problems where you have to write out all your work instead of multiple choice, that free response, showing all this work is necessary. They look for the work on those problems where they ask you to write out all the work. August and then September. So add another 200. And now we've reached the number they told us. They said he wants to buy a car that costs $1,800. We're at $1,800. So now we know, it said by the end of which month. So we're looking for that month. We know the answer to this is September. If again it was one of those free response questions and you had to actually write it out, I recommend writing a complete sentence. Don't just write September. Say, Carlos will have $1,800 by the end of September. Including more information is better than not including enough information. Any other questions about this particular pattern problem? Okay. So another way they like to represent patterns is with figures. They'll show you pictures that you kind of have to interpret. So this says a staircase is being built with blocks as shown in the pattern below. If each square represents one block needed to make the staircase, how many blocks are needed for the 10th figure? So again, we've got to figure out a pattern. They're trying to make you write out an equation, but you don't need to actually get an equation to solve this. You can keep going and just figure out what comes next until we get to the 10th. So we have to figure out, though, how many blocks do we have for each figure. So figure 1, we just have 1 block. Figure 2, we'll go back to a different color. Figure 2, we have 3 blocks. Figure 3, and you literally can just count the blocks. So figure 3, we have 6 blocks. In figure 4, 5, 6, 7, 8, 9, 10. So we have 10 blocks. So again, we've got to figure out a pattern. What comes next? We've seen a pattern where it might change, and we've seen a pattern where we just kept adding the same number every time. we've got to figure out which kind of pattern do we have here. So to get from 1 to a 3, how much do we have to add? What do we add to the 1? 1 plus whatever will take us to 3. Good. 2. If it's more complicated, if the numbers are too big or you have decimals, do the subtraction. Do that opposite to figure out what we're actually adding. How about for the next one? What do we add to get from 3 up to a 6? Good, 3. And then how about the next one? 4. Good. So now we can notice a pattern with the pattern. We kind of actually are looking at a pattern in the pattern. First we added 2, then we added 3, then 4. What are we going to have to add next? Good, 5. Each one of these kept getting 1 bigger. So we have to follow the pattern of adding 1 bigger number each time. And again, I'd write this out in pretty big detail. I'd say, okay, figure 5, 10 plus 5 is 15. So for figure 5, we have 15 blocks. Now we've got to do it again. We've got to get all the way to figure 10 because that's what they told us to do. Figure 6, we've got to figure out what to add again. What are we adding this time? Good. Plus 6. Nope, wrong spot. I'm going to go figure 7. And then down here, what are we adding next? 7. 21 plus 7 is 28. Again, you can always use your calculators. I'm going to have to go down below. I'm running out of room. Figure 8. We're going to do 28 plus our next number of 8. Now it's just kind of repetition. We keep doing the same pattern over and over. Our pattern of picking the 1 number bigger. Figure 9, we're adding 9, which is 45. And figure 10 is our last one, is plus 10. You know, pattern-wise, you can try and do some of this in your head. I lose track of stuff so easily. For me, it's just safer to write it down. Like I literally, whatever scratch paper you use, I don't know if they just let you write on the test or if you have scratch paper on the side, but they usually provide or allow you to use some sort of scratch paper. I would just write it out just to be safe. So any other questions? Let me just make sure we know for sure. The final answer is 55 because they said for figure 10, how many blocks? So 55 blocks for figure 10. Any other questions on this problem? So our next pattern will not be addition. This pattern is going to be multiplication, and we know it's multiplication because of one key word in here. So the question is, a biologist is researching the growth of a certain species of bacteria. That's almost a throwaway sentence. It gives us no good, useful information. He initially starts with 200 bacteria. So there's some useful information. We start with 200 and determines that every 2 hours, the amount of bacteria triples. So when we say the word triples, that's our key word again. Triples means you're multiplying by a specific number. So what do you multiply by when it says the word triples? Good, times by 3. Oops, I was about to write 2, and to write 3. Triples you might see the word doubles. That's times by 2. They could even say quadruples. That's a lot less likely, but it could happen. Quadruples. which would be times by 4. They might have like a divide word if it says half of something. Half or halves is divide by 2. So all just kind of terms you need to have memorized. This is what it means. So every 2 hours, it triples. So after 2 hours, and again, we're just kind of going to make a chart and follow the pattern. After 2 hours, we need to multiply by 3 to figure out where we are at hour 2. 200 times 3 is 600. We also know, and I didn't finish the last sentence, how many bacteria will be present after 12 hours. That's where we stop. So we follow the pattern until we hit 12 hours. But then we just do that repetitive process, keep doing the same pattern over and over. 200 times 3 was 600. 600 times 3, and some of these are going to start getting pretty big. It's 1,800. So even though initially you might not need your calculator, probably eventually you'll need a calculator. And I should point out, every 2 hours, I'm just kind of automatically adding 2, but I just want to point out that that's where these numbers are coming from. After 2 hours, 2 more hours is 4. 2 more hours is 6 hours. So we kind of have to do patterns on both sides until we get to where we want to stop. So 1,800 times 3 is 5,400. We add 2 more hours to get to 8 hours. These pattern problems just get pretty repetitive. So 5,400 times 3 is 16,200.
That's your thesis right there.
Add 2 more, gets us to 10 hours. So we're almost there. Gets us to 48,600. And these multiplication problems, whether it's patterns multiply, you do get really big numbers. A lot of the times we don't trust that the big number is correct. It just seems off. But especially when you're doing multiply, it can get pretty big pretty fast. And then the final answer is 145,800. Another thing to watch out for is they had this 48,600 as one of the answer choices. Make sure you're at the correct stopping point. Just because a number you get is one of the answer choices doesn't mean it's the correct answer. They love putting kind of a number that you would get halfway through the process when you really need to take that one extra step to get to the correct answer.
I used to hate that too.
Any questions on this problem? Once we knew kind of the definition of triples, it's pretty straightforward, but just want to double check. Okay, so here's our last problem for today. All these study sessions will be an hour long, and if you can only make it to like half a session, you're welcome to join in or leave at any time. I do record them, so I will send the links out after this, and you can watch them again, or for anyone who wasn't able to make it, they can watch them too. So the last question, the table below shows the values for a function. Which equation represents this function? Now, function has a very specific math definition that won't always be important. It doesn't actually really matter if we know what it means to be a function right now. We just need a table that matches with an equation. So again, they want you to try and figure out a pattern to make this equation. That's really hard. It's easier to do that method where we plug stuff in to see if we can figure out, well, how is this going to match up? So we're going to take our answer choice A. It says this f of x. This is actually not f times x. I know parentheses usually mean times. We say it f of x. I'm going to ignore that. Really, we can just say y equals x squared. F of x is a fancy way to say y. So what we're going to do is we're going to pick a point on the table and see if it comes out by plugging it into the equation. Multiple choice are great. A lot of them you can just plug stuff in and check it that way. It's not a good idea to choose the one value. Often they'll make more than one answer choice work for that. So we're going to choose the 2, 7. On our table, we know 2 goes with x. It's in the column for x. And 7 goes with y. So what we're going to do is plug in 2 and see if we come out with that correct number. So we're going to replace x. Again, I almost always put it in parentheses just to be safe. Especially when you're working with negatives, it might come out wrong unless you use these parentheses. So 2 squared, you can do it by hand. We know 2 squared means to do 2 multiplied by itself 2 times. Or we can go over to our calculator and do parenthesis 2 end parenthesis. The squared button is next to the 7. It says x squared, and it'll put your little exponent on. And that gives us 4. So we look back at our point and we say, well, our point was supposed to be 7. We got a 4, that's wrong. It is not answer choice A. So again, it gets kind of repetitive. We've got to do that process again, but now we're going to do 2x squared. So we do y equals 2 parenthesis 2. We're replacing x with the number that we picked for x. And then we plug it into a calculator again. 2 parenthesis 2 end parenthesis squared is 8. Now, if you don't want to use the calculator, you can do it by hand, but you have to remember to follow the order of operations. Order of operations says to do the exponent first. So 2 squared is 2 times 2, which is 4, and 2 times 4 gives you the 8, which is still not our correct answer. We wanted 7. So we have to do it again. Got that repetition going again. We have 2x squared plus 1 for C, and we replace the x with the 2 and plug it in again. 2 parenthesis 2 squared plus 1. The nice thing about this calculator is a lot of the time you can just type the whole thing in. You don't have to do any chunks or segments, just type it in, pops out 9. Again, not what we wanted. We wanted 7, so still not the right answer. If you want to be safe, check D. If you're pretty confident, you can just say, well, D's the only option. But if you want to be safe, plug in 2 for D and just double check that it does come out as 7. So 2 parenthesis 2 squared minus 1 gives us the 7. So answer choice D is our final answer. You can try to come up with the pattern doing like what we did before, figuring out what you add each time. Especially with this squared, that's really, really hard. So I recommend for sure on problems like this, just plug in your answer choices. So we are out of time for today. We'll have 2 more sessions next week. Like I said, I'm trying to vary up the times and the days so as many people that can make it can, you know, everyone has different schedules, so trying to accommodate everyone. If you have any questions or anything you want to talk to me about, go ahead and just send me a text message or a Remind 101 message, and I can answer any of those questions. So thanks for joining me, and I hope all of you guys have a great day and a great weekend. I like it, but
So now we get to the climax. Now it's the part that goes